12.3 now. We're basically doing a quick little intro into probability here. So I'm going to give you some examples, and we're going to take a look at this first here. So let's take a look at this problem. It says a card is drawn from a standard deck of cards. I find the probability that it is not a face card. Okay, well there are 52 total cards in a deck. That's the total. Okay, they're telling you that a face card is a jack, queen, or king. So how many face cards are in a deck? Well, you have hearts, diamonds, you have spades, and you have the lucky clovers. So there's 4 suits, and you have a queen, and a jack, and a king in every single one, right? So if you have one in every single suit, just count them up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 face cards. So there's 12 face cards that are out of 52. How many are not face cards? Well, the opposite, right? So 52 minus 12 is 40. So that means there are 40 out of 52 that are not face cards, which we can simplify to 10 over 13. So your official answer here would be 10 over 13 when you simplify it. A card is drawn from a standard deck. Find the probability that it is not an ace. So it's not an ace or. Keyword here is or. Or means that we want to add. So what's the probability that it's not an ace? Well, how many aces are in a deck? There are 4 out of 52 that are aces. So not an ace would be the opposite of that, which would be 48 out of 52. So that's not an ace. Or a heart. Well, how many hearts are in a deck? Well, there is 13 out of 52 that are hearts. Okay, now here's the problem. Find the probability it is not an ace or a heart. Okay, find the probability that it is not an ace, which is 48 out of 52, or a heart. Well, here's the problem. You have to find out what they have in common. Okay, well, what do they have in common? The ace of hearts. I counted it here, or I not counted it here, and I counted it here. So when we add them together, we have to take out what they have in common. So find the probability that is not an ace, which is 48 out of 52, plus the 13. So it's 61 over 52, which is more than 100%. And you can't have more than 100% when you're doing this. So find the probability that is not an ace, which we just did, or a heart. So when you add them together, you know, getting something that is higher than 100% of the time. A number cube with faces numbered 1, 2, 3, 4, 5, 6 is rolled. Find the probability of rolling a number less than 7. Well, how many numbers are on a dice? Yeah, 1 through 6, right? All of them are less than 7. So 6 out of 6, or 100%, is your answer to that problem. Find the probability of rolling a number greater than 1. Well, you can roll 1, a 2, a 3, a 4, a 5, or a 6. A number greater than 1 would be everything up. 1, 2, 3, 4, 5. 5 out of 6. 5 out of 6 would be your probability of rolling a number greater than 1. Find the probability of rolling a number different from 7. Okay, a number different from 7. Well, all of them are different from 7. Not a single one is a 7. So 6 over 6, which is 100%. Right, because there's 6 different, but none of them are a 7. Let's take another closer look here. In your last 15 basketball games, you attempted 60 free throws and made 45. So what's the experimental probability that you will make a free throw in your next game? Well, 45 out of 60 is what you made. And when you simplify that, 45 out of 60 is 3/4. So 75% is what you've been shooting. That's your experimental probability for that one. 120 over 240 is the experimental probability in this one because it says you made 120 out of 240, which simplifies to 1/2, which is 50%. So you're making about half of your goals. In the basketball game, you made 80 free throws out of 100, which is 4/5, which is 80% of your free throws that you made. And then a 6-sided die is rolled 330 times. 4 comes up, so the number 4 came up 54 times. What's the theoretic probability in the experimental? The experimental is what we rolled. And what we rolled was we got a 4 54 times out of 330. That is the experimental. Alright, so keep that in mind, which we can simplify to 9 out of 55. However, theoretically speaking, on a single die, how many 4s are there? 1 out of how many? 6, right? There's 6 sides, one side has a 4 on it. So theoretically, you have a 1 out of 6 chance. 1 out of 6 is 16.6%. We'll just say 6666 repeated. And 9 over 55 is 16.36%. So the point is, the experimental and the theoretical are pretty darn close to each other in this problem. So over here again, 3 comes up 22 times. That's the experiment. So 22 out of 150. 22 out of 150 is 14.6 repeated percent, which simplifies to 11 over 75. But how many 3s are on a die? How many 3s are on a die? 1 out of 6, which is, we already said, over 16.6 repeated percent. So we'll try to finish up probability here when we come back.